time to join this morning. Okay, so good morning, everyone, for today's distinguished webinar series in AI and cybersecurity. The title for today's talk is AI for Social Good in the Era of Large Language Models. With us, Dr. Hong-Zing Hu, Professor and Associate Chair, Department of Computer Science and Engineering from University at Buffalo, SUNY. He is a recipient of NSF Career Award in 2019, Amazon Research Award in 2022. His research spans security, machine learning, and networking. He has participated in multiple cross-university, cross-disciplinary projects funded by NSF. His research has also been funded by NSA, US Army, US DOT, Google, VMware, Amazon, etc. He has published over 150 refereed technical papers, many of which appeared in top-tier conferences such as S&P, CCS, Usenix Security, NDSS, SIGCOM, NSDI, NeuroIPS, ICML, and CHI, and well-recognized journals such as IEEE TIFS, IEEE TDSC, IEEE ACM TON, and IEEE TKD. He is a recipient of ACM SAC Math Test of Time Award in 2024 and Best Paper Award from ACM Asia CCS in 2022, ACSAC in 2020, IEEE ICC, ACM SIGS, CSC, ACM CODA-SPY. His research has won the first place award in ACM SIGCOM 2018 SRC. That's quite a mouthful list of accomplishments. His research has also been featured by IEEE Special Technical Community on social networking and received 50 plus press coverage, including ACM Tech News, Information Week, Slashdot, etc. Dr. Hu, it's a great honor to have you as part of this webinar series at University of North Dakota. Thank you so much for taking the time with us this morning to share your insight on the topic. The floor is yours.
Oh, thank you for for such detailed introduction. So also, I'm very happy to share my research through this talk. So I think we have about 1 hour. Okay.
Yeah.
Okay. So yeah, please just I think during the discussion during my presentation. So if you have any questions, yeah, please just go ahead to interact me, ask me questions. We can discuss any questions when I present. If you have any questions, okay. So okay, so let's start. So yeah, in today's presentations, I just want to discuss some our recent research work, about AI for we call AI for social good. So especially we are trying to utilize even large language models to address some security problems, even for social problems. So so right now, so AI and machine learning. So right now, we can say it's we use AI machine learning to for many different applications, different domains. We have a healthcare domain. We can do even face recognition, image recognition, even speech recognition, even for autonomous driving. So for those domains. So I think right now, so if we discuss large language model, so almost every domains we apply, even science domain, even engineering domains, we apply those new models, even language models, to address some problems. So when we discuss large language model, so we also mention the generative AI. So generative AI is a little bit different compared with traditional AI machine learning. So especially we can see this diagram just demonstrate the relationship between the generative AI, even traditional AI machine learning model, even deep learning model. So generative AI just like a new models. Yeah, especially we want to utilize this model to generate content. So yeah, this is one example about what's the difference between the generative model and the traditional model. Okay, for traditional model, we mainly focus on classification. So we want to utilize machine learning model to classify, try to identify. For example, for this example, so if we give it the image dog, we just this model just tell you, oh, this is a dog. Okay, this is not not other animals. But for generative model, so we want to, if you give the image about dog, so we can see in the model we generate a lot of images. This is just about image generation. right now we discuss a large language model. We try to utilize even those models to generate even content. So this is the current trend. So about we discuss a larger model. So we want to utilize this advanced AI system even to understand, even to generate even human-like we call text, even the content. So that are also even future trend we have multi-model larger model. So you want to utilize those models to generate not just the text, also generate even images, generate even videos. So this is a very future trend. So when we discuss large language model, so we have actually there are some open source, even closed source, or even closed the large model. So for example, for DeepSeek, this is a new model. So right now it's open source. Even for our Llama model, so also is this from Meta, so actually also is an open source model. But for ChatGPT, for Gemini, so those models actually they call closed source, but still you know, so for ChatGPT, we even they also want to even open source some models, even old models, for your users to use. So I think it is something so we can see is there's so many different the larger models we exist. Also we can see maybe see some new models. Also, we can see even those larger model has been applied for education so purpose. For different some universities already utilized larger model for education purpose. So I gave two examples. The first example is from University of Michigan. So they utilize GPT-4 and they build even Daniel, then they build they call the UMGPT. So University of Michigan GPT. So they utilize this model for students, or every student can utilize the model for different purpose. Also, another example from Arizona State, so ASU. So we can see ASU also utilize ChatGPT, to build a very unique model, customized model even for those students. So I believe in the future, so many university will utilize those large model even for the education purpose. So even for UB, so we are also discussing to design our own model for our students. So this some things about we discussed the larger models or right now very popular has been widely used. And when we discuss large language model, so there are some specific technical terms. So one technical term we call prompt engineering. So prompt engineering is a new term, so especially for large language model. Sometimes we want to utilize prompt, and we can design a prompt. So this prompt is just we call a short piece of a text, just like instruction or context. And then so you can, and a larger model will utilize those prompt as an input. And then so based on those prompt, and larger language model will generate, we generate this, we have some control output. So from this model, they can generate text, they can generate image, they can generate video, something like that. So even we have discussed from computer science perspective, so we have discussed prompt engineering will be maybe even some new courses, we can design for to help us to teach us, to teach students, to how to design a good prompt. So this is something. So when we discuss prompt engineering, so there's a lot of concept. We have to emphasize here. So we call chain of thought. So sometimes we can use very simple prompt, for those model. But we can also design very complicated prompt, to guide the model to solve some problems. So one such a problem we call chain of thought. So we can design this prompt, and we can ask the model to solve some very complicated problems. So for example, for some very complicated mathematical problems. So utilize chain of thought. Actually, we can ask a model to solve this problem. So utilize multiple steps. So they can do the logical thinking. So even they can address mathematical problem, even common sense reasoning to address. So here, so we give some examples. So here, so this is the original paper, so published in the 2020, 4 years ago, 2 years ago, 2 or 3 years ago. But this paper actually right now you can see they got lots of citations. So because we utilize those larger model, so we also want to those model to help us to address some problems, solve those problems. But one kind of solution they call utilize this kind of channel sort. So this is example. So if you utilize standard prompt, okay, this model may address this problem, but this model may not correctly address this problem to get the correct answer. But if you can ask the model to solve this problem step by step, even you give some examples, to the model, and ask the model to solve this problem. So we follow these examples. We can see the finally, this model can solve this problem correctly. So this just one example from this paper. But so that means the reasoning, even channel sort of reasoning or risk capability are very, very important, for those, larger models at this moment. So yeah, so when we discuss, this larger model, so we discuss channel sort, discuss reasoning. So here, so I want to just mention a little bit. So right now, actually there's a new trend. We previously discussed large language model, but right now, actually, in the many cases, actually we discuss we call large reasoning model. So we call LLMs. So actually, large reasoning model right now so is very popular. So will be future trend. So here I give two examples. One example from DeepSeek. So because DeepSeek proposed the R1 model, so this is why right now very popular is open source. So many people utilize DeepSeek R1 model to solve those problems. But actually, for OpenAI also have this kind of reasoning model they call O3 model. But we can see right now there's many people, even research, they try to compare. Compare what's the difference between the DeepSeek R1 model and even O3 model. So because those models they are large reasoning model, so not just the traditional the language model. They can also solve some very fundamental even communicative problems or even mathematical problems. So yeah, this is something. So the two examples about reasoning model, but you can see this diagram. So in the right, I just this diagram I just copy from one paper. So that paper, so they just mentioned. So right now, so we are going to they call L2 system. So L1 system just traditional larger model. L2 system just we focus on reasoning model. So this diagram just shows, there's a trend about reasoning models. You can see, especially from this year. So at the beginning of this year, we can see there are so many new models, about reasoning model. So they utilize reinforcement learning. They utilize many different technologies even to train the model and to address some very comprehensive problems. So this will be future trend. I want to emphasize. So yeah, this I just give an overview about even larger give a concept, just also the concept about generative AI, or the concept of larger model. Also, I just discussed a little bit about the reasoning model. You discussed the channel sort, and then so we can see right now those reasoning model, most of the reasoning model they utilize channel sort technology, for reasoning purpose. So this is the new trend, for the AI machine learning. Okay, so let's see. Because in this talk we mainly focus on security and safety problem. So let's think about. So we utilize larger model to generate content. So the major question so right now. So safety and security is one big problem. For those large language model. So here I give an example here. So actually, we utilize those large models to generate content. But those content may cause even misinformation. Even they can also generate malicious content. This is what we call malinformation. Even they can generate deep fake. We can there are many examples. We have deep fake something. So this may be even disinformation. So those larger model can be also utilized by malicious people. So malicious guy, even we call misused by those guys to generate those misinformation, disinformation, even malinformation. So this is why the safety alignment is very important. So we want to guarantee those model cannot be utilized by those malicious users. to misuse by those malicious users to generate even we call malicious even malicious content. So this is why even those large model, so they have been trained, okay, to be safe. So they have utilized different technologies. They can use pre-training, even they can use supervised, okay, fine training. But recently, so even OpenAI, they mainly utilize reinforcement learning with human feedback, okay, to guarantee those model to be helpful, even honest, even harmless. So this diagram just shows, okay, there's some technology have been used, okay, try to guarantee, okay, this model they are safe enough. But the problem, so even though those model has been okay trained, okay, to be safe, so we call safety alignment, but still those model can be easily attacked. So we still can see so many attacks against those models. So I give some example. One is about jailbreak. Jailbreaking is why is new attack, especially against the large model. Even there are some other okay attacks. They call palm injection, palm leakage. Even we can still do the backdoor attack against those model. Even we can do the data leakage. Even there's some privacy problems for the model. So here is one example about jailbreak. So actually, so it's very simple. So normally, so we don't want this model to output okay malicious content even. But if we utilize some specific okay prompt, you can see in the model can still output okay those malicious content, malicious okay the content. So this is why we can jailbreak okay those models. But okay, this example actually is a very old example, about 2 years ago. But right now, OpenAI has fixed okay those problems. So, but we can still see some new jailbreak attacks. So yeah, this something. So the model has some problems. Okay, we can attack those okay larger model. But okay, on the other hand, we can also utilize those larger model to address some safety and security problems. So for example, so we can also utilize large model to detect even toxic content. We can detect online hate. I will give you some examples. So we have some papers about hate speech detection. So utilize large model. Even we can utilize large model to detect phishing attack, even fake news, even deep fake. So you can see there's many. Actually, we can utilize large model, yeah, to do those detection. So we can also utilize large model for traditional cybersecurity problems to address those problems. For example, about malware detection, we can also utilize large model to build even intrusion detection system. So actually, we have one project, okay, about try to utilize transformer to build an intrusion detection system. Also utilize large model to explain, okay, those output to generate defense rules. So even we can utilize large model to do the fingerprinting. So that means the many traditional security problems can be also addressed, okay, by a larger model. So we can see there's actually right now there are two research directions. One research direction, we try to address some fundamental problems we're seeing, okay, those large model. And then so we can also utilize large model to address some traditional security problems. So here I just give some many focus on how we can utilize okay generative AI, even larger model to address to we call social good. So we mainly focus on how we can utilize large model to detect the first topic about detect online hate. So that means hate speech detection. And also we can see even the second topic we'll just discuss how generative AI can be utilized even for children game. So these two special problems. But later, if you have time, so I will discuss a little bit about some other works. So actually, we also utilize large model for 5G system, even for code analysis. Even we'll also utilize large model for many other problems. Yeah, I will discuss yeah a little bit. So later. So actually, so we have done okay a couple works about utilize generative AI for online hate okay detection. So hate speech detection. So actually, we have two papers recently published. Okay, one paper published last year in the S&P, and we mainly focus on detecting okay new way of online hate. So exactly we utilize chain of thought reasoning okay to address this problem. And we have a lot of papers so actually present last month. So in the NDSS. So yeah, this paper we focus on the first paper. We focus on the text-based hate speech. The second paper we focus on the harmful means. So harmful means that means this is multimodal problems. We have text, we have image together, and we try to address how we can utilize the multimodal large language model, okay, to understand and detect harmful means. So there's some ongoing work about hateful video detection, even how to misuse to generate hateful means. So those work actually I just discuss. We may discuss a little bit. So for the first work, so we present last year in Auckland. So we mainly focus on how we can utilize large language model to address to detect and hate. And yeah, this some motivations actually we can see. So we have some new wave of hate, especially if we have a COVID pandemic. So and also something other issues can happen before. So even and when we have those events, actually we can see in those online social networks we can see so many new hate speech happened, new type of hate speech happens in the social networks. So even actually we can see those for existing system, even for Twitter, for Facebook, we can see actually cannot address those new wave of online hate even well. So because we can still see so many new wave of online hate. So that means those system, existing system, even Facebook, even Twitter, we call X, and actually don't have very. Maybe they can design a solution, but they didn't enable those solutions to address those problems. So actually, we have collected data set from tweets. So we can see collect data set, and this data set can contain three type of hate speech, new kinds of hate speech. So related to the COVID, related to the U.S. capital interaction, even the Russia invasion. So we collect this data set and we label this data set, and then so we find some patterns from those data set. So we can see for each kind new wave of hate speech, normally they have three stage. They have build up stage and a peak stage, and then they can they call decline stage. So if a new event happened, we can see that build up, they have peak. So and then after a while, this those will be declined. Those number of the hate speech will be declined a lot. So this is just a pattern. So for those new wave of hate speech, and so our goal try to build a system. So that means when those kind of new wave of hate speech happened, in the online social networks, our system can detect those new wave of hate speech, and then so we can significantly reduce those hate speech. So this is our major goal. So then so we want to develop a system, and especially to detect those hate speech during the build up stage. So we have tested all existing system. So actually there are some existing detection tools from different companies, from IBM, from Amazon, even from Google, but we utilize our data set. We can see from this, from our measurement, we can see all those existing systems cannot address those new wave hate speech very well. So we can see high score for those systems are very low. So why? Because those existing systems actually they cannot. Normally they have to train by neighbor data. So we should have a large neighbor data to train this model, and then those model can address those problems. So this takes a long time. You can see for existing system, it takes almost a couple months to address those new problems, emerging problems, because they need a large data set. We need to label this data set, and then we need to train this model, and then we can deploy this model. So here, we want to know, so can we utilize some new technologies? For example, can we utilize zero shot, even virtual learning, to adapt to those we call rapid change, in this concept, even in the we call in the new wave of hate. So new wave of hate, that means it just happen very quickly, and they are very new. We don't have enough data set to train the model. So then, can we just utilize those zero shot, even virtual learning, technology, to address this problem? So this why we design a new system. So is very complicated. Well, context well. So we did reasoning. Okay. Also, we don't have enough data set. So can we, let me see, even sometimes there's no samples or few samples. And then so can we update the model? So this is the design goal. So right now, exactly large model, so it's good. Okay, is very good to address okay those challenges. So why? Because in larger model, so we discussed they can support a chain of thought. So chain of thought prompt can be utilized for reasoning purpose for decision making. Also, we can also utilize automatic prompt even to update. Okay, or utilize existing knowledge. Okay, in the larger model, and we just use that some few examples. Okay, to automatically update those models and to address okay those problems. So this is why, so yeah, this is the problem and the motivation. So we design we call a system, we call hit guard. So the system. So in this system, we can see in the first step, we try to collect okay new wave samples. So because yeah, those new wave samples just happen okay in the short time, so we can collect a few. We don't collect a large data set, just a few samples. And then so we utilize these samples to identify some new target term, and we use even keyboard to identify those new terms target, and we then we verify novelty. So let me start, we just add some new terms okay into our data set, just database okay, and we utilize those terms, new terms and target to generate okay the prompt we call hit COT prompt. So this prompt and then so we utilize those prompts okay to against okay those existing larger model, and then so we go through this kind of process. Okay, actually our system can be automatically expand. So based on if it has new samples, we just add some new target terms. We through this kind of okay, we call hit COT prompt, and then we can up the model. So based on this system, we can see all the system can be automatically featured by our system, and we can update models, and then so we can utilize those those we based on some few examples, we can build this system, and we can utilize this knowledge to detect those new wave of hate speech. So this diagram just shows how we can utilize hate COT, the PALM strategies. So exactly we utilize the chain sort. So we just ask the model to check some target, to check some even direction, to check some specific terms, and then so they make a decision. So they make decision step by step. But for more details, actually, you can take a look at our paper, so we don't have time to discuss those details. So the chain sort can be utilized, to enable model to detect, those new kinds, we call new wave of hate speech. So this is an example. So if you use traditional model, traditional approach, actually this is I give you example here. So this is the new wave hate speech based on COVID. And if you give this this example this traits to traditional model, actually you can see the traditional model just say this is not hate speech. Okay, but if you just directly ask a larger model, so this is hate speech a lot, we can see we call use that general prompt. Actually, the model still say this is not a hate speech. But if we utilize our hate COT, our system, so we just ask the model to check, this sentence, one by one. So use multiple steps. And then so we can see our system actually can successfully detect, this is the hate speech. So yeah, this is just one example here. So we have evaluated our system. So based on our data set, so we can see without our system, actually we can see, those new wave hate speech happened. But if we utilize our system, actually we can see significantly reduce, those new wave hate speech. So even at the beginning, even during the startup, the stage. So yeah, this is something we have compared. We also compare our system with many existing systems, even bot-based, even Twitter, ERP. So there are some existing system. We have discussed a commercial system, even something there's some other research, research work, related to this kind of hate speech. So we can see our system, our overall results. Our system can achieve almost even above the 90% detection successful rate. So compared to other system, they have just 70%, even 80%. Okay, 80% detection success rate. Sometimes our system actually can achieve very high detection. Okay, successful success rate. So this is something. So I just discussed here. We have identified there are some new challenges, especially for new wave hate speech, but we need a new system to detect this hate speech. So in this system, so in the hate guard, okay, we build a system based on large language model, and we also utilize channel sort of reasoning, okay, to address those new wave hate speech, so we can achieve very high success rate. Okay, so any questions about this? It's just the first work we just discussed.
I think we'll reserve the questions at the end, continue. I think,
Okay. So let's continue. So yeah, we can even any question we can ask. You can ask them questions or even later. So this is the first work. So we focus on text-based hate speech detection, but we have a lot of work. So we call this new papers we present. Okay, even last month in the NDSS. So NDSS also is a lot top security conference. But in this work we focus on multi-model. Okay, large model. So we call harmful means. So here, so I gave examples about actually we know, so we have utilized this means, okay, for communication to deliver, to disseminate, okay, the information on the social networks. So many people utilize, okay, to design this mean. So what do we mean? So the mean, that means we have image and text together. Okay, we put image and text together, and we send the means, okay, to the social networks, and this can be utilized to deliver some information. But this kind of means can also be utilized, okay, in the dark side. Sometimes we will have harmful means. So here I give example. Yeah, this is the harmful means, especially related to COVID. So before, so but problem. So how can we detect? Okay, this kinds the harmful means. So because we have images attached together, so this is a Chinese problem. So we call actually the harmful means detection actually is a Chinese problem. So actually this we have a data set. So we call this one data set from Facebook. We call Facebook. This is Meta. So data set. The Facebook harmful means data set. Facebook has this kind of data set 3 years ago. Actually, there's a computation. So actually initiated by Facebook. So because Facebook found this is a very Chinese problem. So they have the initial computation. So many team can participate in this computation before. So Facebook released this data set contain even 1,000 the means. They contain about 500 means, the harmful means. And this data set is a fundamental data set. Actually, we have utilized this data set to measure some existing work about harmful means detection. So from this table, you can see they have some existing work. They call explain even HM, even some Llama model, some commercial model, even GPT-4V for those model. We can see use some existing work, even a commercial model. We can see the average, the detection rate is just even less than 40%. So for those model. So let me say, okay, those existing model, no existing technology actually cannot address this problem very well. So that means the harmful means detection still a big challenge. So why this harmful means detection is so challenging? So we can see actually there are two problems, two challenge problems. Okay, one we call composition, the means composition. So here I give you a couple examples. So the different kinds of means, even can based on the number of panels, we can see there are single means, they have even stitching. So that's sometimes we put a multiple images together, so combined, okay, the can generate means. Even they have different type of images. There are photos, screenshot, even illustration, even have different skill. They have close up, even mid shot, even long shot, something, even have different motions. So physical, emotion, even conscious. So here, this diagram just shows, the different type of means. So actually, it's a very challenging problem. So we cannot utilize very simple tools, to detect, those means. Also, another challenging problem for means, we call means propaganda, technology. There's many different, even there are 22, propaganda technologies have been used, to disseminate, those means. So that means that we should understand, those models should understand, okay, those propaganda technologies, and then they can successfully detect those means. So we can see, if we utilize propaganda, even without propaganda, actually those tools, existing tools, actually can be significantly reduced, or the detection rate can be significantly reduced. So these two major challenges. So based on these two challenges, actually, we have developed a new system we call HMC. So this system actually, we mainly design this system to address harmful means problem. We utilize, okay, we call multimodal large language model, okay, to address this problem, but we still utilize chain sort of reasoning approach. So this is a step for our system. The first step, we identify detection challenges. We have seen there are three major challenges we call multimodal, okay, semantic fusion, even have means composition problem. They have means, okay, propaganda technologies. And then so we try to address those three challenges, utilize we call the chain sort reasoning. We do the adaptive prompting. We will have some reasoning reasoning prompt, and then we have a decision making prompt. So and then so based on those, okay, the prompt, we give this prompt to multimodal large language model, and then so ask the model to answer some questions. So based on chain sort. So this is okay, the basic step. So for more details, actually, you can also take a look at our paper. So actually, we give some examples, okay, in our paper. So even we have open source our system. So yeah, based on this system, actually, we checked. So this diagram this figure just shows the comparison between our system and some other existing system, even commercial system, even ChatGPT. So you can see our system can achieve very high based on these two data sets, can achieve very high detection rate. So we can achieve some, even for the first data set, we can achieve over 80% detection, okay, success rate. But even for the second data set, sometimes we can also even achieve even 90%. But you can see for other system, actually, so they can only achieve about 6%, even 70%, okay, detection even rate. So this is the second project actually. So we try to utilize the multimodal large model to address some we call harmful means, okay, problem. So we still utilize, okay, chain of reasoning. So there are some things, other challenges we try to address. The major one challenge we call harmful video. So even in those social networks, we can see, so we can see identify so many, okay, harmful videos, even harmful videos. But video detection is a lot of big challenge problem. So for means detection, we mainly focus on images and text together. But for video, we also include voice. So this is more challenging problem. So we try to address. Also, we also try to address a lot of problem we call harmful means, even hateful means, okay, generation. So here we give two examples, okay. So if you utilize this example, so you can test many existing models. So utilize this prompt. One is the DALI model, the DALI E3 model. This is mainly used for ChatGPT. Even they have a stable diffusion model, even majority. So those models actually mainly utilized right now, utilized for generate even to generate, okay, the multimodal the content. But you can try this very simple prompt. Those prompt can generate, okay, those we call harmful means, even hateful means. So it's easy to generate. So that means those model they have done okay, safety alignment, but they cannot, okay, do safety alignment about the multimodal generation. So right now, so this is the big problem. So we try to address right now. Okay, so this about we just discussed how generative AI can be utilized for harmful content detection. We discussed even new wave of hate speech detection, harmful means detection. Even we are doing even harmful video detection. So those things actually is some ongoing work. Also, we have finished some work. Also, do some ongoing work. So the second topic we just discussed, how generative AI can be utilized for children game. So this is also a lot of interesting problems we try to address. So the the first topic about generative AI for unsafe children game moderation. So we last year we published paper in the user security. So in this paper we talk about how we can moderate, we call illicit, online image promotion for those unsafe, the children game, we call user generated content game. So but we utilize large region language model to address the problem. Actually, we have some ongoing work, for those topics. So you can take a look. So I just discuss a little bit. So as I mentioned, so we presented this paper last year. So in the user security, and the major problem for this for this topic. So because right now we have so many online user generated content game. So especially Roblox. So I know maybe everybody knows Roblox. So even for my case, actually my son, so actually he played a lot of games in the Roblox. But in the Roblox, actually many games are generated by users, by others. It's not generated by companies. So just users design a game and they publish game. But we found actually in the Roblox, as there's many games we call unsafe games. So Roblox is very popular right now. You can see has been used a lot. But we found there's some unsafe, user-generated content games, in the Roblox. You can see there's some news. There's many news has discussed, those problems. So let me say, right now it's a big issue. So because for those kids, they play game, but those games, they are unsafe games. So in the system, in the Roblox. But we also find, many users, even malicious users, they utilize even the X, even trace to promote all those games. So here I give two examples. So, this is a real example. So where I just got a screenshot from trace from X. So many people they utilize those traits, even the Facebook, to promote the games. But we can see some games actually they are sexually related. Some games just violated in the game. So they just attract the users to play this game, even some children to play this game. So this is a problem. So actually there are some promotions we call some malicious user, they try to utilize social networks to promote those games, but unfortunately, even Facebook, even X, they couldn't moderate those promotions. So here we collect a data set. We collect a data set and we compare. So we compare we try to identify some new challenges. For compare some state of art unsafe image detectors. So we have some tools. So those tools actually generated by Yahoo, by Amazon, by Microsoft, Google. So and we can see for traditional, even malicious images, actually so those detectors can be easily detect. This is the sexually related images, but for those games, user-generated games, this is the image. But such an image we can see for those existing tools, they couldn't detect those images successfully. And the best tools, the Google Vision AI, they can only achieve less than 70%. So I'm saying this is the real problem. So for we should address. So yeah, to address this problem, so we design a system. So recently we designed a system we call UGCG Guard. So we collect data set from those social networks, from X, even from Facebook. So we collect large data set. And then we also design the UGCG COT prompt, also based on the channel sort of reasoning. And there are two kinds of reasoning approach. One we call domain adaptation. So we try to tell those tools, those model. So actually, this is the specific problem for children game, and also we do some contextual identification. So based on different some factors, and we try to identify those UGC or the game images. And based on this prompt, we utilize the region language model. We give this prompt to those region language model. And also we try to check those models to make this thing to identify, those are safe or unsafe, those images. So this is the basic system. So for more details, you can take a look our paper. So we have done the evaluation. So this is our system, and we compare our system with some other commercial systems. Well, Google system, Google Vision AI we just mentioned, so can achieve even the best performance. So for those children game the images, the promotion images is achieved about 68%. But if we can see our system can achieve almost 94% detection accuracy, the detection rate. So our system can significantly improve the performance. So compared with those existing even commercial systems. So yeah, this is something. So we have done. So even future work, we can see in-game moderation will be very important part of what we should address. And actually, there's many challenges. So for those in-game moderation, they have chat, they have text, even they have voice. So there's some video. So we also need to do the voice detection, video detection, and then we can detect those specific problems, even harmful content, harmful video, harmful voice. We see those games. Even there's a lot of problem actually right now. Generative AI has been widely used for those companies, even for Roblox. They try to utilize, even integrate the generative AI for user to develop games. So we can see, we have discussed those generative AI can be utilized, even to directly design those malicious games. So this may be big challenge. So right now, the generative AI is very powerful. So LLMs can be utilized to design those malicious games. Those games also, they are very powerful. Okay, it's hard to detect. Okay, those games. So this will be another big problem. So we should address. Okay, in the future. So yeah, this is something. So yeah, we see. So can we trust those generative games? So without those safety alignment. So because those model, we do the safety alignment, but those model can be still utilized. Okay, for misused. Okay, to design those maybe unsafe to the game. So we did some mechanism to protect this model. Even we did some design some defense tools, okay, to moderate, okay, those system. So this is about game design. This is about focus on children games. So we just discussed some, gave you example about the image promotion. So for those games in the social networks, we design system to detect, okay, those we call unsafe images. But also in the future, exactly, we need to design new system to moderate those games. So inspire those games actually they're video based. So how can we moderate those games? Okay, is a big challenge. Okay, it's a very big future trend. So we also have some ongoing work. Okay, for try to utilize larger model. Okay, to address some problems. So one work. So here I just discuss a little bit. So we have published papers, or even we have presented this paper last month, also in the NDSS. There's a workshop they call Future G workshop. So we want to utilize large model to detect vulnerabilities, even repair those vulnerabilities within the open source 5G system. So 5G and 6G is a future trend. Right now has been widely used. Also they are open source 5G system. But we can see there's still have so many vulnerabilities within those systems. But how can we detect those vulnerabilities? How can we repair those open vulnerabilities within the open source 5G system? So actually in this work, so we have demonstrated that we can utilize large model to help us to detect those vulnerabilities. Even we can utilize large model to fix those vulnerabilities. So if you're interested, you can take a look at our paper. So we also have recently have two new papers for youth security, so even for this year. So we are present those work even I think this May. So one paper so we talk about how can we utilize still utilize large model to detect real world software vulnerabilities. So how can we patch those vulnerabilities? So we can do the automatic patching generation for the vulnerability. A lot of work we focus on try to address the jailbreak we have discussed. We can use jailbreak attack against those larger model. But how can we defend those attack? We call jailbreak attack. So this is still a big challenge problem. So we have a lot of paper. We talk about how can we defend a large language model from jailbreak attacks. So we utilize the concept analysis and manipulation. So we call GAB shed. So this paper. So we design this tool. So actually, we have the open source this tool. So if you are interested about jailbreak attack and defense, you can take a look at our paper. So this some actually there's a couple ongoing work. So about a larger model, as I mentioned. So and there are two directions. One direction, we try to attack those model. Also, we try to do defense. Okay, defend some attacks. For example, the jailbreak attack against those larger model. Okay, even we have discussed large reasoning model. So right now, even for my student, they are working on how can we attack those reasoning model. So yeah, this is a new challenges. So we try to address. Okay, the large actions we discussed, we can also utilize those large model as a tool. Okay, to address some traditional security problems. We discussed the hate speech detection, even we discussed children game, malicious children game image detection. Even we can utilize that model for deep fake detection. Even we can see those model can be utilized for vulnerability detection. So for code analysis to detect the bugs, okay, in the code. So we have a demonstration how can you utilize for open source 5G system. So even when we can utilize for mobile detection, we can also utilize to build even intrusion detection system. So actually, there's many areas we can explore. So to utilize even those large model to address some traditional security problems. Okay, so I think we have to I don't have time to discuss details, but I think I just give a brief overview about some existing work. About larger model for social good, even for some network security problems. So if you want to know more details, you can go to my website and you can take a look at those papers. So if you have some questions, yeah, please feel free to ask me those questions.
Thank you so much, Dr. Hu, for fascinating chain of things that you talked about, ranging from this chain of thought prompting. I was making notes of different things, looking at text and audio, multimodal, and different guard system. I do like your acronyms, what you come up with. I think all these maybe
Many
machine.
things, yeah. Many things we can do, yeah, we can see, yeah.
Yeah, so it's good. So we're opening for questions now, so folks can able to put their questions on chat, and maybe I'll start with some question. Okay, most of the talks actually talked all the models that you talked about. You talked about using LLMs. And do you see when LLMs are going to be exploited you talked about three things: speed, reasoning, and cost. When we evaluate, how quick we can able to detect these things, right? And how do you see this trade-off between, when new models come up, and at the same time, there are real threat and ethical concerns of these, LLMs can be exploited, and how do you see this balance between these trade-offs?
Yeah, actually, so this is a good question. So this is a very good question. So we can see we can utilize IM for many because this is general AI, so already have been used, have been widely used. I believe many people, so almost everyone, so right now. So for us, we try to utilize ChatGPT for our work, for our work. So in the future, because right now a lot of trend they call agent, AI agent. Exactly those foundation model, those large model will be utilized widely for different system. Even many people will build the agent and for the work. So this exactly that means the large model is very useful. Okay, but a lot of problems we know those large model they are not safe. So there are some security problems. Okay, can
Sure.
be misused. Can be misused exactly. So even we discuss something, they can be misused to generate malicious content. They can be used for even for attack. Right now, there are some people they utilize those model to generate attack, explore. Okay, try to try to attack the system, attack the networks. We can see those agents they're very smart right now. They can do better than the human at this moment. So exactly uh, actually there's many discussion about so because we know those large models they are unsafe at this moment. They are not they still we need to do very strong even have safety alignment but still has some problems can be misused. But on the other hand, we still those models they are very powerful. We want to use those models. So I believe so the same thing. So we cannot wait. Okay, we cannot wait. Okay, because no models okay they are perfect. So
Sure. Yeah.
we need to utilize them. So for yeah our job, but actually so security executive is very important. So that means even when we utilize the model, we should know those security problems, and then so we try to avoid those problems. Also, we as a security for researchers or even we should build some tools, okay, to help others, help users, okay, to even to when they utilize those models, we can help them to detect, even to moderate, okay, those system, moderate the generated content, even to help them to understand, okay, those problems. So I think it is something, so lamps we can prevent users to utilize those model. But I think as a research, even security experts, security researchers, so this is our rule.
Sure.
Okay, responsibility, yeah, to build some system or to help users. Yeah.
And I have another question. If you can go back to study one when you showed that
Mhm.
temporal patterns, of that hateful hashtags thing from Twitter, you mentioned about these temporal patterns to counter the peak of a new wave,
Yeah.
right? And what is the goal of that? Do you want to catch that peak, or or you want to track? No, I didn't quite understand that tracking the countering the peak of a new wave. Could you talk on that? When you
Yeah,
say,
this is just like a motivation. So we just want to see, for those new wave, okay, is a new for the new wave of hate speech. We can see they happen. They have three stages. That's they are built up stage. So that's we cannot see too many, but actually in the peak, that's we can see in the short time we can see a lot of okay the new wave hate speech happen okay in the Twitter in the social networks. And then so after a short after maybe a period of time, okay, you can see they can decline. So that means that we really want to build a system, okay, to detect okay those new wave, okay, at the beginning. So even before they know this kind of will go to the peak, we should detect them, we should prevent them. So if want to damage, okay, this is the motivations. So that's not, but at the beginning, so during the build up stage, but we don't have enough data set. But how can we detect? So it's like a motivation.
sure. We have a
Yeah.
couple of more questions. Thank you for that. I think,
Okay.
given the high energy of consumption of training LLMs, what strategies can be adopted to make AI development more sustainable? And there's very generic questions, but you know,
You mean
uh,
energy? Could you speak again? So let me see.
it says, okay, what strategies can be adapted to make AI development more sustainable? And as we see more and more LLMs being trained,
Yeah.
you know, uh, you know, I think that's I'm not sure what sustaining in this context means, uh, but maybe that's just a generic question. Shriram, do you want to ask specifically what you're thinking when?
Yeah. Yeah. Specific. What's a specific problem? So I know there are so many models right now. So many models. Yeah. In many companies want to train those models. Yeah.
We have another question from an adversarial perspective. Can you share your thoughts on how explicit content detection can be evaded, even with a chain of thought querying? For example, how successfully can hateful memes or content be presented in context typically associated with non-explicit themes such as educational?
Yeah. Right. I think this is very good question. So, context based. Okay. Actually, for those his speech. Different people may have different perspective, okay, for his speech. Yeah. So let's say even we found out this is not an easy problem. So we did a cultural background even from the different countries. Yeah. So this is why we did integrate, okay, some yeah, specific content. Even there are some explicit, okay, the means for those case speech. So this is why it's not simple problem, so we cannot just build a simple, even right now, so we can achieve very high, a little bit high success rate, but still there's many challenge problems we need to address. Okay. But I think it is something, yeah, still the content is the context based. So I think still there's many research challenges there. So even right now I don't have a specific answer about this one. How can we build a system can address all those problems? As I think it's very hard, yeah, problem. So
Yeah.
but we build a more comprehensive system in the future to address the problem. Yeah.
I agree. That's a hard question. I think that's a good question. Yeah. And the next question, great presentation. As DeepSeek is non-compliant on many offices or premises, what prompting strategy can we use to bring DeepSeek capabilities in GPT-o3 Mini that utilizes raw weights for logical reasoning that is applicable for secure coding practices?
You mean the security, okay, security coding practice? Okay, this is good question. So for exactly DeepSeek and even OpenAI, maybe they may have different features. Maybe even do the prompting, maybe we use it. Even I know, so OpenAI, they utilize the human, okay, they use the human feedback, okay, to refine the model, even for reasoning. But for DeepSeek is a rule based. So actually they utilize totally different approach, even to train the model, to the reasoning model. So that means the strategy should be different. So my suggestion is try to understand, okay, try to understand some maybe okay, even the reasoning training process, and then you can build maybe better, okay, the prompt, okay, and then you can utilize the DeepSeek, those models. But for security practice, you mentioned about security coding practice, as I mentioned, it's about coordination problem.
Yeah.
Yeah, actually, this is a lot of interesting problem. So we have, actually we have paper. So we just submit the paper to we submit paper to SEECS. So we try to utilize security coding practice, even to just as a rule, try to enhance, strengthen those models. So DeepSeek is one model we try to strengthen. So because those model we can see those model we try to many people utilize those model. They call AI coding. Utilize those model to generate code right now. And this may be a future trend. So in the future, maybe we don't need okay super engineers. They just utilize those AI model to generate code. But we can see right now, the still those models they are not perfect. We can still find okay there's so many vulnerabilities bugs okay to generate by those code, those models because those models just trained by GitHub, the data set from GitHub. But GitHub actually contain those code, those code actually can already they have bugs there, they have vulnerability there. So that's why those models can still generate vulnerable code. So
Cool.
we try to utilize okay the secure coding practice. So secure practice is just like some rules, okay, principles, okay, to guide the model to generate code. Sometimes we don't need previously, so most of the model just trained by existing code, even GitHub code, but then this code still have vulnerability, so this is why the model will generate vulnerable code. Okay, but if you utilize secure code practice as a principle, actually we have papers on right now still under submission. So you utilize SAP, we call secure coding practice. We call reasoning graph because those SAP there's some dependency relationship. We utilize graph-based reasoning, okay, to fine-tune the model, to teach model, and then so we just and then so we try to stress model, okay, to generate more secure code. But still, we cannot achieve 100% okay secure code generation, but we can significantly improve okay those model. So I believe yeah, the secure code practice SAP is a good principle okay to integrate into model even for especially for reasoning process to code generation.
Super.
Mm.
Thank you. I think we'll conclude with one more final question that I have, and I think I just want to, for you listeners, when you talked about these four different techniques for jailbreaking, prompt injection, prompt leakage, backdoors, and data leakage, which one is more frequent do you see, or also in which one is harder, and what type of reward modeling that most commonly used, that in the context of LLM reasoning?
Yeah, actually, so we can see I mentioned about some attacks before. Okay,
That is, yeah, it's,
yeah, yeah, you got it exactly here. Yeah, as I highlighted here, so exactly jailbreak. Okay, now jailbreak is a big problem, is a new problem for larger model. Okay, because yeah, we don't want those model to generate okay, malicious content. Even we don't want the model to generate okay, unsecure code. So so the insecure code. So jailbreak is a big problem. So for larger model right now, but we can see so many researchers okay in this area. they propose some new jailbreak attack. Even we have new papers I mentioned, so just accepted by user security. We focus on how can we defend a jailbreak. Okay.
Is that your term, jailbreaking, or is it a standard term that people came up with? Jailbreaking. This.
Jailbreaking something, jailbreaking is a good term, something, yeah, right.
Anyway,
Yeah.
it's so much fascinating. I think we learned a lot today. Thank you so much for your time this morning with us. I think we should collaborate on working on proposals and different things as we do. I think and I think I'll be reaching out to you. But I think this is fascinating webinar. You will receive a nice plaque from UND for your
Yes, thank you.
contribution today, and a nice letter from our dean. And thank you so much for being with us this morning. I think I look forward to working with you, as in terms of collaboration.
Okay, so even for this any other questions, yeah, please you can send me emails to reach out me, so I'll be very happy to answer any questions. Okay, even
Good.
clarification, no problem.
Sounds good. Thank you, Dr. Hu.
Thank you.